Hello, hello, my friends. I hope that you are comfy and feeling good wherever you're at and you've been having a good day, finding something positive and exciting in your day. Take a second to just relax and get grounded into this activity. We have 11 slides here that we're going to look at in this Desmos together. At any point, pause the video if you need to take a break, step away, and you want to pause and come back, or maybe you're taking notes. That's totally fine. As we go through this, we're going to answer the questions on each slide and then go to the next slide. We have 11 total. So we have this line here on this graph, and it says put a point on the line. So we want to type an x comma y ordered pair to put a point on this line. So if we're looking, there's a few points that are on this line that I see. Here's one, and we want to find the points that are like exact grid line points, okay? So I see a bunch of examples on this line. You can choose any of them. I will choose this point here, which is at -2, 5. Oops, it put double parentheses. And I'm going to hit share. And it should graph your point, and that point should be on your line. And then push ahead to slide 2. Find a solution to this equation. Type in x comma y that is an ordered pair to this equation. So our equation is y equals x plus 2. So whatever x is, we add 2 and we get our y. So if I say, let's say x is 5, we would have 5 plus 2 would equal our y. 5 plus 2 is 7, so that would mean our y coordinate is 7. So this point, 5 comma 7, is on this line, right? We took our x, which is 5, and we added 2. What's another point that would be on this line? Try to think about another one. If we started with a 0, 0 plus 2 is 2. So 0 comma 2 would be the point, right? The rule is whatever x is, add 2. So if we had 10 is our x, add 2, our y is 12. These are all examples that are going to be on this line. I'll take 10 comma 12 and hit share, and then push ahead to slide 3. So here's your ordered pair plotted. I was like, where is it? It's so high up there, y'all. My ordered pair that I did, 10 comma 12, is way up here, where x is 10 and y is 12. So we see our point. Is your ordered pair correct? And it is, because it's on the line, right? If the point is on the line, then it is a solution to the line. It makes the equation true, and we love that. That means we have a solution. Anything here using your own words to explain that, and then hit submit. And then push to slide 4. What does it mean for a point to be a solution to a linear equation? For example, if I say 2 comma 5 is a solution to this equation, how would you check my claim? So we have our point 2 comma 5. So this means our x is 2 and y is 5. Okay, so our equation is y equals 2x plus 3. So let's plug in 5 for our y and 2 for our x. Hopefully you see how I did that. I'll highlight it to show you. Right, x is 2, so wherever I saw an x, I put a 2. Y is 5, so wherever I saw a y, I put a 5. Okay? Great. Now we simplify. 2 times 2 is 4. 4 plus 3 is 7. This is not true. So since this is false, it is not a solution. So what we're doing here, to be a solution, it must be a true statement after you plug the point into the equation. Beautiful. Whenever you feel good, push ahead to slide 5. Look at these two lines. Is there an ordered pair that is a solution to the linear equations describing both of these lines? Are these two lines intersecting, and where? So we can see that, yeah, these lines are definitely intersecting. And we see that happening right here where they cross, X marks the spot. So we could say these two lines do intersect. So they have one solution at the point -4, comma, +1. So what I'm looking at here is this point, which has an X value of -4 and a Y value of 1. Beautiful. Push ahead to slide 6 when you're ready. Look at these two equations. Is there an ordered pair that is a solution to both? So we don't have a graph here. We're going to learn other ways to solve for solutions using algebra, using substitution, using elimination as the weeks continue. What we're thinking of, is there a number that we can add 1 to, and we will get a Y value? And then we plug in that same number, make it negative, add 5, and get a Y value. So let's try out the number 1. Let's say, well, what if X is 1? Y would be 1 plus 1, which would get us 2. For the next equation, if X is 1, Y would be a -1 plus 5, which is 4. So that does not work. 2 and 4 are not the same. Let's try the number 2. Y equals 2 plus 1, which is 3. And Y equals a -2 plus 5, which is also 3. Haha! So since these are the same, the point 2, 3 is a solution to both. Now, we would figure this out using elimination as the weeks continue. And I'll give you a little preview to that. What that means is when you have two equations and they're lined up like they are here, you can actually add the equations. 1y plus 1y is 2y. X plus -x cancels out. 1 plus 5 is 6. Divide both sides by 2, and we would get that Y value of 3 like we got before. We're going to look at that process later in 2 weeks from now, but this is just like a little preview as to what that's going to look like, okay? So I'm going to hit yes. We found that the point 2, 3 is a solution to both equations. I don't know why I just yelled that. Push ahead to slide 7 when you're ready. So this says that's right. When you have 2 or more linear equations, it is called a system. The solution to a system of linear equation consists of the x and the y value that make both equations true. Graphically, this appears as the point where they intersect. In this case, the solution is 2, 3, like we found. If you are trying to decide whether a system of equations has a solution, would you rather have the equations or the graph? That's your choice. Do you think it's easier to find the solution if we see a graph or if we have the equations? So you're going to answer this on your own because that's your own opinion, and make sure to hit share and then push ahead to slide 8. These two lines represent a system of equations. What is the solution? So these two lines, they do intersect here. We see X marks the spot. What is that coordinate? Our X value is a -1. Oops. And our Y value is also -1. So it's the point, -1, -1. When we plug that in, you should see that dot appear right where that intersection is. That's how we know we did it correct. Slide 9 when you're ready. Does this system of equations have a solution? Now, we don't see the intersection point, but I do want to show you something. If I draw a line and keep extending this line, because that's the thing about lines, is these lines go on forever. We're only seeing a small part of the graph. Here's our second line. They will eventually intersect. It is just going to be off of the graph. So even though we don't see it, if we can tell that they're going towards each other and they're gonna cross at some point, then yes, they have a solution. And I want you to use your own words to kind of explain your thinking there. How do we know that these two lines will cross? Well, we can tell that they're slanted towards each other, getting closer and closer, right? When we think about the distance down here, it's much larger. And then as we increase, our distance is getting smaller and smaller, and eventually they will cross. Slide 10, when you're ready. Does this system have a solution? So notice here, the distance between these two lines stay the same. It never changes. They don't get closer or farther apart. These are parallel lines. They have the same slope and will never intersect. So there is no solution to this system. Beautiful. Finally, slide 11 when you're ready. Graph two lines whose solution is 1, 4. So we have the point right here. So if we were to figure this out, let's see. Let's say here's our y-intercept. I'm just picking a number 7. So the slope from that point 7 y-intercept down here is going down 3 and over 1. Down 3 over 1. Down 3 over 1. So there's our line that has this -3 over 1 slope. So it's a -3x, and our y-intercept is 7. So there's the first line. I'm going to graph it here. Does it? Okay, there's my first one. Oh, there we go. Another line that goes through that same point, pick a different y-intercept, it doesn't matter. How about 1? And then the slope from 1 to 4 is going up 3 and over 1. Up 3 and over 1. So that one has a slope of +3 and a y-intercept of 1. So we have y equals 3x plus 1. And there we go, they intersect. There are an infinite amount of answers to this extension problem that is using any slope and y-intercept that's going to make it so it goes through that solution point of 1, 4. Remember, no, that's it. That's our last slide. So when you have a second, make sure you're submitting this in Schoology. If you need help from me, if you have any questions from me or want support, please let me know. Y'all rock it. Keep working through this. We're going to be finding solutions to systems throughout the next few weeks. This is just our first method, which is graphing. Take care, my friends. Enjoy the rest of your day.